All right, guys, that last video was really long. I'm going to try and be more succinct in this one so that it doesn't take as long to go through. But just remember it's not like you do the video and then you do the worksheet. The video goes with the worksheet, and that's the only assignment you have for the day. So I just hope I'm not taking up too much of your time. But yeah, let's go ahead and jump in. The first thing I'm going to do is I'm going to write and I know I'm going really fast now because I'm worried it's going to take too long. So remember to drag the video back and forth, pause, whatever you need to do. If you're doing it like one question at a time, pause it right now, do number one, and then check at the end with me to see if your answer's right, type of thing. But yeah, the standard form of ellipses are going to look like a circle to start with. H always goes with X, K always goes with Y. These are equal to 0 and not R squared. And then you've got your denominator. So you have A squared and B squared in the denominator. So technically the order of these doesn't matter because it's addition. 1 plus 2 is the same thing as 2 plus 1. But what I recommend is when you're thinking about ellipses, thinking about the upper half, the denominator, or the numerator as fixed, okay? Always, always, always in your mind, have it be X term plus Y term. This is really going to help when it's differentiating between ellipses and hyperbolas. So in ellipses, the numerator stays fixed and the denominators can switch back and forth. So what that means is while the tops stay the same, their denominators can change. The B can be under the X or the A can be under the Y, okay? Again, this is going to help when just keeping the rules of hyperbolas and ellipses straight in our heads. So if we think that the top is fixed and the bottom moves, we need to keep in mind that A is greater than B. And so by switching which denominator it's in, all it does is really tell you whether it's going to be more of like a horizontal ellipse or a vertical ellipse. So when the bigger number is under the X term, remember the X axis is horizontal. So it just means that the ellipse is longer horizontally than it is vertically. So it's going to look like a sideways football. And then when A, the bigger number, is under Y, Y is vertical distance because Y is the vertical axis. That just means that the ellipse is going to be taller than it is wide. And so it's going to look more like a vertically oriented ellipse. That's basically what that A and B do. Remember, A is the distance to the vertices, B is the distance to the co-vertices, and C is the distance to the foci, and then C squared equals A squared minus B squared for ellipses. So let's go ahead and take a look at our equation and start graphing. The first thing I'm going to do is I'm going to grab my center out of this. So my center is going to be flip the sign 3, 0. And then I'm going to plot that on my graph. So once I have my center, I'm going to look at the two denominators and I'm going to choose which one is A. Well, I'm not going to choose. I'm going to decide based on which one's bigger. So 49 is the bigger number, which means 49 represents A squared. 9 represents B squared. Therefore, A is 7, B is 3. So I know that A is the distance to the vertices and A is underneath the Y term. Y axis is up and down. So that means I'm going to go 7 up and 7 down. That's my vertices. And then I know B is my co-vertices. B is underneath the X term. X is the X axis. It goes left and right. So I'm going to go 3 to the left and 3 to the right. So if I were to jot down those coefficients, the vertices will have the same X coordinate, and then one's 7 and one's negative 7. And then the co-vertices are going to have the same Y coordinate, and one's going to be 0, 0, and one's going to be 6, 0. And so from there I can sketch my ellipse. That one's not great, but it's not worth redoing, so we're going to keep it. And the foci, now we have to figure out what the foci is. So we can find C by doing A squared minus B squared, which means C squared is 40, which means C is the square root of 40, which is divisible by 4, which means we can call it 2 root 10. And then you can type that in on a calculator to get like a more of an estimate of what that number is. It's more like 6.3. So that'll help you like put your foci point in there. I'm going to go 6.3 in each direction, and that'll help me draw. Well, now I have to redraw this because it excludes the foci. So I'm going to try again. There we go. And then you can see my purple dots are my foci, which are in there. The foci are always in line with the A term. They're always in line with the vertice. Remember, think vertice and co-vertice, like captain and co-captain. The one that doesn't have the co in front of it is more important. And so the foci are always going to go with the more important one. I don't know. There's a bunch of tips and tricks that I could give you guys to keep this straight. The good news is we're most likely going to take this test through online learning. So, you know, you will be on your own doing this. You'll have access to things to help you. So then, yeah, those coordinates would be, they'll have the same x coordinates, so it'll be 3, and then it'll be 6.3. They made this one really easy by giving us a 0 coordinate and negative 6.3. To be actually correct, we should do 210. These are trying times that we are in right now. If you put 6.3 and negative 6.3, I don't think I'm going to count that super wrong, but you should be doing it in the rationalized radical form, okay? So please let me emphasize that it should be this version right here. I was wrong to do it that the first time, but again, we're in a global pandemic. If you have a decimal, that's the least of my worries. So then let's look at number 2. You're going to look at it and you're just going to find that center. Hopefully, you know, your brain is really good at picking out symmetry. You can try and make sure you got it right. So you can count 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Beautiful. 1, 2, 3, and 1, 2, 3. So not only did that verify that you have your center point, but it also gives you your A distance and your B distance. And remember, I know that this is A because it was the bigger distance. I know B is the smaller distance. So that means this is the vertice and this is the co-vertice. And so it wants us to write the equation. And honestly, that's all we need to know. Because to write the equation of ellipse, you need the center, which we've got. It looks like our center is at 0, 2. So our center is at 0, 2. And then our A is 7 and our B is 3. So I'm going to throw that in an equation. Remember, again, assume the numerators are fixed. Assume they don't move at all. So it's going to be x, and it's just going to be squared because we're not going to write plus or minus 0. We went over that in the last video. Flip the sign, y minus 2, set it equal to 1, and then we look. A is in the horizontal direction. The longer value goes left and right. So that means that a squared is going to go under x. And then b value, the smaller value, goes up and down, which means b is going to be under y, which is 9. Moving on to number 3. Like I said, this stuff, it's just always better to plot it. Just think about it on a graph. That's the way I do it. And it really helps visualize it a bunch of times. So we are at 6 over 10 up over here. And then we've got negative 20, 10. So this is 6. Negative 20, 10 up here. And then my co-vertices are at negative 7. And then 20, oh gosh, 22 up. Dang, that's really high up. Negative 20, or at 22 up, and negative 2. So, bam and bam. So, the distance between the vertices is a spread of 26. And so that means that A is going to be half that distance. Sorry, I just got really thrown off by that 22 being such a large number, but let's refocus. So the distance from the vertices is 26. From positive 6 to negative 20 is a 26 spread value, which means the center is going to be halfway in, which is 13 on either side. And then the co-vertices are a spread of 20 apart. Of 24 apart. And so then their distance is going to be wow, I can't talk. I don't know why that 22 is bothering me, that it's such a big number. So the co-vertices are 24 units apart, and so halfway would be 12. The really easy way to find the center when you're given the co-vertices and the vertices is that it's the term that overlaps. So like these two share a 10, so that's the y coordinate, and then these two share an x, and so that's the x coordinate. So your center is going to be -7, 10, which you can see it makes sense because -7 is halfway between 6 and 20, and then +10 is halfway between +22 and -10. And so we need that distance A. So if the vertices are 26 spaces apart, A is 13, and then we need that B value. And if the co-vertices are 24 units apart, then their B is 12. And then that's all we need to write the equation. So again, think of the numerators as fixed. They don't move. Make sure you flip your signs. Set it equal to 1. And then your vertices went in the horizontal direction if you look at the coordinates. And so that means that A goes under the x term because x is the horizontal axis. And so 13 squared. And then your B values go up and down. And so that goes under the y term. And so B squared. And then that's your equation. And then we'll do vertices and foci, and then we'll complete the square on this one. Again, I'm really trying to do this one quickly, but hyperbolas and ellipses are way more complex than circles and parabolas. So I'm doing my best. So again, plotted on the graph, bam, bam. We've got 0, 10, and we've got -20. Really extend this. 10. We'll call this -20. That's my vertices, and then my foci are at -4, 10. So -4. Ooh, this is not drawn to scale well. I apologize. And -16, 10. So we can see that since our vertices, maybe it would have helped if I drew. No, it would not have helped if I drew this. I'll draw this one because I didn't mess up the scale too bad. So this is our ellipse. It is horizontally oriented because our vertices extend left and right. So we need to find the center. The center is going to be smack dab in the middle of these 2 points. They actually make it really easy for us by centering one of them at 0, because I know if it goes from 0 to 20, that halfway through is going to be right in the middle at -10. So I'll make that a different color. That's my center right there with coordinate -10, +10. And so now that I have that, I need to know my distance from the center to the vertice, which is my A distance, and that's going to be 10 from -10 to 0 or -10 to 20. And then I want to know my distance. Remember, distances are always positive. If you were wondering why it's not -10, because distances are always positive. I don't know my B value, which I need, but I do know my C value. I know the distance from the center to the foci, which in this case is 6. And so I'll use my C squared formula to find B squared. So I'm going to do C squared equals A squared minus B squared. And I get 36 equals 100 minus B squared. And then that's going to give me -64 equals -B squared. Get rid of the negative on both sides. Square root both sides. B equals 8. And now I can write my equation. So again, think about the numerator as staying in the same order. Flip the signs on these guys. Y minus 10 squared. Set it equal to 1. A, since it expanded horizontally, it's going to go under the x-axis. So A squared is going to go under x. and then b is 8. B is my co-vertices, and so since they are not the vertices that were horizontally axised, then it's going to go under the y term, and then b squared is 64. That's my equation. And then lastly, I've got to complete the square. This is kind of like last time where we're going to have to factor a term out, but the first thing I'm going to do is my grouping step. Again, I'm totally winded doing these videos. I do not have my teacher breath support anymore. So 4x squared, group it with the 80x because they both have x terms, y squared, group it with the 10y because they both have y terms, and then the 229 is getting subtracted on both sides, which means we've got a negative 229 on this side. So now the next thing I'm going to do is I'm going to complete the square and also factor out anything if I need to. For example, this should be 80x. For example, right here, I'm going to pull out a 4 so that my x squared is positive and singular, which means I've got to divide 80 by 4. So I'm going to have 20x now, and then half of this middle term squared, so half of 20 is 10. 10 squared is 100. And then plus the y is good to go, so it's going to be y squared minus 10y. Half of negative 10 is negative 5, but we know that a negative squared is always a positive number, so it's positive 25. Again, that's important because what you do to the left, you have to do on the right, and if you did it the wrong sign on the left, you're going to do it the wrong sign on the right. Okay, so we had negative 229. I added a 25 on the left, so I have to add a 25 on the right. And then I did not just add 100 on the left. If I were to expand the complete left side of the equation, I would eventually do a 4 times 100, which means I actually in value added 400 to the left side of the equation. So I have to add 400 to the right side of the equation because that is what I added to the left. So now I'm going to change these polynomials into factored pairs, and then instead of writing the pair, I'm just going to write it squared. So I've got 4 times x plus 10 squared. Again, you don't have to think hard where that number comes from. It's always half of the b term plus y minus 5 squared equals, and then we have to figure out, as I do with my iPhone calculator, what 425 minus 229 is. And we get 196. And so now the last thing we have to do, the reason that we get these denominators that we're used to is because the equation has to be set equal to 1. So I divide by 196 on both sides. And then I reduce the fraction, so I figure out what 4 over 196 reduces to, and so I'm going to get x plus 10 squared over 49 plus y minus 5 squared over 196, and set it equal to 1. And again, like I was saying in the circles one, you know that you're right when you start to see those perfect squares. So 49 is 7 squared, 196 is 114 squared. So like this part is where you guys go the most wrong, I notice. So start using your math intuition, and that's where I always have hope. Like I've got 229 plus 25 plus 400. While I'm writing that down, I don't really know what that's going to be, but I hold my breath, and when I type that into my calculator and I see a perfect squared or a number that's going to reduce to a perfect square, that's when I exhale and I know that I got the problem right. So once I saw 196, I knew I was good to go because that's a perfect square and it's going to come out to a nice, pretty equation. So again, I'm going to try and stop talking so much. Again, I'm running out of breath, but I'm going to jump down into hyperbolas and then hopefully power through this second half of the worksheet and make this one a little bit less time, but honestly, it's probably going to be as much time, if not more. So the general equation for my hyperbolas, you've got the same thing, x minus h squared, except now it's separated by a minus. Minus y minus k squared equal to 1 with a squared over b squared. So now This is why I asked you to think of the ellipses numerators as fixed, because the a squared and the b squared could be under each denominator. Didn't matter because it was addition. Now it matters the a and the b. A will always come first. And again, think about it like alphabetically. You know, A is first in the alphabet, so A is going to come before B. So you can, these are fixed, okay? But you can switch the numerators. So you can have y minus k squared come first, minus the x term. But a squared is always going to be the first denominator. B squared is always going to be the second denominator. So again, in the ellipses, think about the numerators being fixed, and you can flip the denominators. In hyperbolas, think about the denominators being fixed, but you can flip the numerators. And remember, hyperbolas have the negative sign or have the minus sign in the middle. So then, that's your hyperbola generic equation. When x comes first, your parabolas are going to open left and right. When y comes first, your parabolas are going to open up and down. And so one of the best ways I have to help you guys remember that, and again, this could totally suck for you, but when I see them like left and right, I can, oh, that's a horrible color to use. I like imagine seeing the X, and now I know you're going to tell me that when they're vertical, you can see the X too, but when they're vertical, I always picture this as a Y. I don't know, that's just always worked for me in my brain over the years. I started learning conic sections back in like 2013, and this is still how I remember it. So yeah, again, I'm really sorry. I know they both look like X's, but the way that I do it is when X is first, that's when they open left and right and it looks like an X. When Y is first, that's when they open up and down and you get that barrel that you would be able to use for your Y. Again, that's the best I've got for you. In addition, your foci, your C, again, your A is your distance to your vertices, your B is your distance to your covertices, C is still the foci, except now you find it by doing A squared plus B squared instead of minus. And then also you have your equations for your asymptotes, and I'm not even going to write those out now. We'll get to those when we get to those. So let us take a look at number 6. We're going to identify the foci, the vertices, the foci, and the asymptote of each of them, and then we're going to sketch the graph. So the first thing, so your hyperbolas still have a center, okay? Even though we don't really use it, the center helps us plot all of our points after that. So it's still important to use that H and K and find your center. So this center here is going to be positive 1, positive 1. So now from there, A is always the first denominator, so A squared is 15. B squared is 15, which means A and B are both the square root of 15. And then for plotting that on a graph, you can just type in the square root of 15 on your calculator. It doesn't simplify, and so it's about 3.8. So that can help us a little bit try and figure out what that distance is to plot. So I'm going to go about 4, 1, 2, 3, and then a little bit more on each side, 1, 2, 3, and a little bit more on each side. That's my 3.8 in the A direction, which is horizontal because it's under the X. And then I'm going to go 3.8 in the Y direction because it's under the Y, which is vertical. And so it makes a perfect box, actually. If I can sketch this nicely. Ooh, which I totally blew it on the last corner. So that means that this point right here is my vertice. I know that the vertices are always the ends of the parabola. So again, if you can't remember this horrible trick that I gave you, you should know that A is your vertices. So that means that if these are your vertices, then your parabolas have to be, your hyperbola has to be here and here. So that's another way to help you remember that when the X term comes first, they're going to open left and right. And so let's see, it asks for our vertices. So let's go ahead and write them. Our vertices are all going to have the same Y coordinate because they're in a horizontal line. But the way I'm going to write it, I'm just going to take the original coordinate and I'm going to add the square root of 15 because that's when I went to the right and it's got the same y coordinate. And then for my other one, I'm going to do 1 minus square root of 15 because that's when I went to the left and then it's still got the same y coordinate. My foci, I have to figure out what c is. So c squared equals a squared plus b squared, which means c squared is 30. And let's figure out what the square root of 30 is so that I can plot that on a graph. Whoa, sorry. Sorry, I only pressed the wrong button on my calculator approximately 57 times. So the square root of 30 is about 5.5. For all intents and purposes, it's the square root of 30, but for plotting it on the graph, it kind of helps to think about like where 5.5 would be. So I'm going to plot that. And so again, if you're wondering why is it plus when it used to be minus, that's because if you think about it in an ellipse, the foci are always going to be inside the ellipse like these guys were. Because if you think about it, like these are your two parabolas. Like this is a parabola and this is a parabola. And so remember, your parabolas are always the bowl of cereal and the foci is the cereal. And so then if you look down here, this is adding them together because that would put this foci right here at 5.5 and this one at negative whatever. It's about right here. And so that foci is always in the bowl of cereal. So that's why it switches to plus, because it needs to extend farther from the center in order to be inside the parabola. But yeah, and so to write that distance, that foci, again, since they're all in a horizontal line, the foci, the vertices in the center, it's going to be 1 plus the square root of 30. That's going to make it go to the right. It's going to have the same y coordinate. And it's going to be 1 minus the square root of 30. And it's going to have the same y coordinate. And that's going to send it to the left. And then the last one is finding the asymptote. So when the x term is first, your equation of your line is going to be plus or minus, because you're going to have two of them. You're going to have one with a positive slope and one with a negative slope. B over a x minus h plus, okay, that's your vertex form. And so plug that in, y equals root 15 over root 15, x minus 1 plus 1. And then 15 over 15 simplifies to 1. X minus 1 plus 1 simplifies to just y equals x. If you left it like this, if you wrote y equals x minus 1 plus 1, that's not wrong. Again, global pandemic, we've got bigger fish to fry if you left it like that. But it is just plus or minus x. So we've got plus or minus x in that direction and plus or minus x in that direction. And those are my asymptotes, which force my parabolas to look the way they do. So that was a lot, but that was our first example. And then they get a little bit easier because they don't ask for all the information. So writing the equation was pretty easy. You're going to need to know your center. So find that. You want to know their distance to your vertices, 1, 2, 3. That's A. And then your distance to your co-vertices, 1, 2, 3, 4. So 3 and 4. And this distance is B. And that's really all you need to know. You want to notice that they open up and down, which means the y term is going to be first. Again, whenever I see it opening up, I think like that's the y. I don't know. That helps me remember it. I'm really sorry if you hate that and it doesn't help you at all. But maybe it does, and maybe it helps one person, and it's worth it. So yeah, I know that y is going to go first. My center, I didn't even write down. My center is at -1, +2. And so remember, the y always goes with h, or the y always goes with k, the x always goes with h. So this is going to be y minus 2 right here. And then it's going to be squared minus x plus 1 squared. Set it equal to 1. And then A is always first, B is always second. Remember, it does not have a qualification which number is the bigger number or not. It's just A is always first, B is always second. So A squared is 9, B squared is 16. And we done. Beautiful. Again, 8 and 9, you already know what I'm about to say. We're going to draw the graph ourselves because it's so much easier to just visualize it on a graph. My vertices are at 3, -4. Again, let's see if I ruin the scale of this completely. 3, -4, and -11, -4. And then my co-vertices are at -4, 0, and -4, -8. Okay, that's not that bad. I didn't ruin that one. I don't know if I want to draw it, but let's see what I draw. Nope. I think I did mess up the scale of it. It's not going to be pretty. Ooh. All right, I give up. Sorry. So my vertices are going, oh, duh, I'm drawing an ellipse and it's a hyperbola. That's why it's not working. Oh my God, please do not flame me in the comments of this or on Google Classroom. We got to draw our little box. Oh, I'm so stupid. Again, please don't make fun of me. All right, horrible box, but there it is. Again, to find the center is really easy because you just pick the coordinates that overlap. So these two share the y coordinate, these two share the x coordinate, so my center is going to be at -4. -4, which makes sense if you go ahead and plot it. If you go to -4, -4, -4 on the x is halfway between 3 and -11. It's 7 in each direction. And then -4 is halfway between 0 and -8, and it is 4 in each direction. And so we know that the distance of the vertices is A. The vertices went out horizontally, so this is A. And then the co-vertices right here are B. And then that's all we need to know to write our equation. Well, we do need to note that if these are the vertices, then that means that these are the parabolas / hyperbolas. And so that means that the x term is going to be first, okay? Because A is always first, and the A is the vertices, and the vertices were horizontal. So x is horizontal. Just a bunch of different ways to think about it. Flip those signs, square it, subtract, flip the sign, square it, equal to 1. A always goes first, A 7, square it. B is 4, square it. Done, easy breezy, beautiful, cover girl. On to the next one. This is going to be one, where we're going to have the A and the C term, and we're going to solve for B. Hopefully you're just getting familiar with this pattern by now, and we're almost at the end. So I'm going to stop talking, and I'm just going to start working. So I'm going to draw my graph. Vertices, this is at 8, -2, so 8, -2. Ooh, yeah, talk about ruining the scale. Oh, sometimes sketching a graph is hard. That should help me. So this is 8. We'll call this -2. And then we'll call this 14. And that should help. So the vertices is at 8, -2, and 8, +14. Nope. And -14. Oh my gosh. I'm way too far into the video to start over. So we're just going to have to love me for who I am and how I can't draw graphs. So 8, -2, beautiful. And then -14 is down here. Great. My foci are at 8, +2. Oh no, +2. And 8, -18. So what that does is that tells us how our parabola is opening up. You could have done that with just the vertices. You didn't really need the foci to know which direction that it opens up, because if the vertices go vertically, then you know that it's going to open up and down. But we can sketch a little graphy if that helps. Okay, so things that we need. We need to know the center. Again, it's really easy to find the center. Oh, no, just kidding. We don't have the co-vertices. That only works if you have the co-vertices. We know that it's going to be in line with the vertices, so we know that the x-coordinate is at least going to be 8. And then we want to know what that distance is right there. So we want to know what is halfway between -2 and -14. So that's a 12 spread, which means we want to go 6. So -8 right here is going to be my halfway point. So again, the distance from the two vertices was 12. So the center is going to be halfway through, which is 6. So add 6 to -2 or subtract 6 from 14. And that's how you get that center coordinate. And then the distance, we need to know A. The distance from the center, we just talked about that, was 6. And then we don't know B, question mark. And then C, the distance from -8 to 2, that's the foci, that's a spread of 10. Or -8 to 18, either way it's a spread of 10. Again, if you're asking, why isn't it negative? It's because distances are never negative. So yeah, we use our equation. C squared equals, oh, I should plug in C. 10 squared equals A squared plus B squared. 100 equals 36 plus B squared. 64 equals B squared. You could go ahead and solve for B. Honestly, we only need B squared for the equation, so you could stop right there. So yeah, I'm going to throw this in my equation. Since the parabolas open up and down, again, I don't know if you hate this, but when it opens up like that, I see the Y, and that reminds me that, oh, I knew it was going to do that. That Y needs to come first. So my final answer, I'm going to have Y, flip the sign, minus x squared equal to 1. A always comes first. A squared is 36. B always comes 7. B always comes second. B squared is 64. And then last but not least, one more completing the square problem, and then we are done. We will review live together next week for the test review, again, just so that you guys can ask questions in live time, or if I say crazy, confusing stuff on here, you guys can stop and be like, what the heck did you just say? And just that good collaborative learning environment that I miss so much. So let's go ahead and finish this out. First thing we're going to do is group x squared minus 18x minus y squared minus 2y, and then subtract that 44 on both sides. So I've got a negative 44. So now we're going to complete the square. I've got x squared, half of negative 18 is negative 9. Negative 9 squared is positive 81. You have to factor out this negative, okay? That is not just minus x squared. That is negative 1 times y squared. You cannot complete the square if there's a coefficient. You also can't just leave that negative and put the y in here and not factor it out of the things that you're also going to try and put in the same parentheses. That's mathematically illegal. But you can put the negative on the outside as long as you factor it out of everything else. So take that negative out of the y squared, take the negative out of the 2y, and now you're good to go. You can take half of that 2, which is 1. 1 squared is also 1. And then balance out your equation. So I added an 81. There's no coefficient, so that's it. It was just an 81. And then over here, I know it seems confusing, but you had the negative and then a 1. So there's not a positive 1 on the left side, and there needs to be a positive 1 on the right side. There's actually a negative 1 on the left side. So there needs to be a negative 1 on the right side. And so that we're able to start completing the square, or we're able to factor. Sorry, we already completed the square. So again, you don't have to think about that number. You created it. It's always going to be half of that b term. So x minus 9 squared minus y plus 1 squared, and then equals whatever 81 minus 45 is. And then again, you should have that sigh of relief when you type that in your calculator and all of this ugliness simplifies to a perfect square. That's just chef's kiss. You know that you've done it correctly. And then you're going to get some denominators because this has to be equal to 1, which means you're going to divide both sides by 36, which means these guys have the same denominator. No problem with that. And they're perfect squares, which is exactly what we're looking for. And bam, that's our final answer. So those are your reviews. Let me know if you have any questions. I can Google Meet with you and do a problem one-on-one. Or if you think I got something wrong, please comment. Or not on the YouTube video so the world can see, but like comment on Google Classroom where it's just between you and me if you think I got an answer wrong and I need to correct it, because that's totally possible. But yeah, so I'll zoom out right here. If you want to just use this as an answer key, pause and check your answers. And then I'll zoom down here. Again, if you would just want to use this as an answer key, pause and check your work. And yeah, I love you guys. I'm really, really, really looking forward to having live class with you guys next week, and just to see, even if you mute your video, just to hear your voice or see your face for 2 seconds before you turn off your video. But yeah, I love you guys so much, and I miss you all the time. I think about you every day, and I love you guys.